In this lesson, we're going to focus on one of the methods for solving quadratic equations. The form that we'll work with for these quadratics will be standard form. So it's ax squared plus bx plus c. There are three methods. There's graphing, factoring, and quadratic formula, and there'll be lessons in each of these. So right now we're going to focus on graphing. So we're going to deal with a function that's in the form ax squared plus bx plus c. And what we want to find when we ask to solve is where does the graph cross the x-axis. And another way to think about that, when the graph crosses the x-axis, we're going to find where is the y value equal to 0. So quite often these expressions are going to be written as ax squared plus bx plus c equals to 0. And that equals 0, we're asking what x values give a y value of 0. Now we can do that through those we have on the worksheet there. We're going to switch over now instead and look at the graphing calculator. So from your handout, we have examples 1, 3, and 5 here. To graph these, I have it stated as y equals, and we'll see what happens when you change that to 0. But if you type it in as 0, you're going to see some different results than what you're expecting. So right now, either you keep it as equals y or just leave it out. I kept it there as equals y. And then you have your quadratic. So to find where the graph, where the y values are 0, just keep in mind your y values on the y-axis here. If we take a look, 6, 4, 2, 0. So y equals 0 would be where does the graph cross the x-axis, where the y values are always 0. So anywhere across this line, the y values are always 0. We want to find where does our quadratic intersect that line. And if we take a look, we can see it here. It's at negative 3, 0. So an x value of negative 3 and an x value of 2. So these are our solutions. The x value of 2 and the x value of negative 3. They're the roots or x-intercepts of our quadratic. If you take, just keep in mind these two values, negative 3 and 2. If you take your graph and say make it equal 0, then you might think that you've done something wrong here. But what it's doing is still giving you those answers. It's just giving you two straight lines at an x value of negative 3 and at an x value of 2. That's where you cross the x-axis. So if you type in 0 and you don't see the quadratic shape, well, really what it's done is solved it for you. It's found those two values. And if we just replace that 0 with a y, again, these values still persist there. All right, the second graph on your sheet, 2x squared minus 5x minus 3, where does that cross the x-axis? And again, you're only interested in the x values here. So at an x value of negative 0.5 and an x value of 3. So we don't need to write it as ordered pairs because the only thing we're interested here are just the x values. And you can't expect to have decimal or fraction answers. And for the fifth graph on your sheet, so where's the graph cross the x-axis? And here it's a double root, so it comes down, hits the graph, hits the x-axis, bounces off, and does that once here at 3, so x equals 3. And just to show that again, so if you replace the y value with 0, you get a straight line through what your answer would be, 3. Another way these could be presented to you would be that the equals would have a value there, or another equation there. So with this quadratic, we have x squared plus 2x equals negative 1. Now you do have the option of bringing the negative 1 over and solving that quadratic. But what we're going to do here is treat the left side of the equation and the right side as two different graphs. And we'll again show this in the graph calculator for a little more clarity. But when you graph these, as you can see in the first one here, the x squared plus 2x, that's a quadratic. So we've graphed that one here. We've got our quadratic. And then we'll graph y equals negative 1 here. So you make both of these graphs equal to y. And what you're looking for then is the intersection point. What's the x value that solves that? And what we see from our graph here, the x value that solves this intersection is -1. And we'll look up one more here, then we're going to shift over to our graphing calculator. So let's look down here at one that would give you two different equations. So you have 5x equals 3 subtract 2x squared. So it's important that one of these, at least one of these, has to be a quadratic. So here you have one that's quadratic, it's on the right side. So when this is graphed, 3 subtract 2x squared, you have a quadratic that points down. And 5x, y equals 5x, would be a straight line graph here. And what you're looking for then is what are the x values where they intersect. So the x values here look like it would probably be a half, and then at -3, but we'll verify that in a moment on the graphing calculator. So we'll look at several more examples. And here, with number 4, we have two quadratics are equal to each other. Now remember, this is still a quadratic, 4x times x plus 3, because if you multiply it out, you'll have 4x squared plus 12x. You still get your x squared term. And sorry, this one's not a quadratic, it's linear. It gives you a straight line. And again, graphing both, you're looking for where they intersect. But we'll do both of those in a moment on the graphing calculator. Okay, so we're back to our graphing calculator here. And what we're going to do, we're going to graph those same examples we just seen there and see here how it works when you're graphing them on the calculator. So here's your first equation, x squared plus 2x equals -1. Again, if we try to graph that right away on the calculator, you're not going to see the same graph as what you did on your worksheet. And the reason being, it's just going to give you a straight line telling you what the x value is. So this straight line here represents what the answer is, the x value of this straight line. And our answer should come out to -1. So let's just make that go away. And we're going to graph both sides of this equation. So our first one here will be y equals x squared plus 2x. And then we're going to graph y equals -1. So the first one will give us our quadratic that we were expecting. And let's zoom in just a little on this one. And then we'll graph our second one here. So a y equals always gives you a straight line. And it's a horizontal straight line. And it's a straight line at -1. So let's zoom in here a little closer. Let's see that y value here is -1. Straight line. And we're looking for the intersection point. And we focus just on the x value. So your x value here, so let's make that go away. So your x value here is -1, which is what we seen there a moment ago when we tried to graph the full equation at once. Back here. Still, x value -1. So we graph them both separately, and we're interested in just the x value of the intersection. Here's a second example that we looked at. 5x equals 3 subtract 2x squared. So it's written in a different order. You're not seeing the x squared in front. So, but -2 is still your a value. This would still give you a graph that points down. 3 is still your c value. That's your y-intercept. And 5x, any equation that's written just as an x value, will be a straight line. So try and graph both together here. Again, it doesn't look like the graph that you've seen there on your sheet. It tells you just what your solution is. So the x value will be -3 and 0.5. But to see how that plays out with the graphs, let's graph y equals 5x. So we'll graph the left side. And then we have a straight line. And then we'll graph our quadratic. And what we're looking for are the intersection points. So this is one intersection point. The x value is 0.5. That was one of them we had seen. And if we look for our other intersection point, here, the x value is -3. And we zoom in just to make sure we have the right point there. And we do. So -3 and 0.5 were our intersection points. And that should be the same as what we had seen. So just remember these values, 0.5 and -3. So we try to graph both together. All it gives you would be the intersection points. And then our third example that we looked at, we have 4x bracket x plus 3. So this is a quadratic, because if you multiply it out, you'll have an x squared term. And then you have 3 bracket 4x plus 3. And that wouldn't be a quadratic. So we're going to have a quadratic and a straight line. Graphing them, we will get solutions of -1.5 and +1.5. So just remember these x values, -1.5 and +1.5. And we should get them as intersection points when we graph the left side and graph the right side of this first equation. So here, one intersection point is -1.5, and we should get +1.5. Looks like it's there, and we do. So that's one way to find the roots or solutions of a quadratic.